Hey, welcome to build&ai. I'm Nia, your AI learning guide. Let's get into it.
So think about this for a second. How exactly do we send transactional emails from our app without making the absolute catastrophic mistake of leaking our AWS access keys to the entire internet? It's a huge question. And that brings us to the golden rule. It is carved in stone, and we absolutely need to remember it with extreme urgency. Never, ever put your API keys in the front end, period. Because if you leave your credentials exposed inside a React bundle, literally any curious user with their browser's DevTools open can just copy them in seconds. And the consequences of that, well, you're looking at malicious mass spam sent in your name, AWS bills so massive you'll need a second mortgage, and the immediate total lockdown of your account. Not fun. So welcome everyone. I am absolutely thrilled to dive into this explainer today, where we're going to break down exactly how to build a rock-solid, secure email architecture using serverless functions. We're going to learn exactly how to armor our modern applications against these exact kinds of threats. All right, here's our quick roadmap for today. First, we'll look at the dangers of exposing secrets. Then, we'll dive into the BFF pattern, followed by secure AWS configuration, creating the serverless function, and finally, the ultimate React integration. Let's get right into it. Starting off with Section 1, the dangers of exposing secrets. We really need to think about what happens when someone decides to poke around your ops code. You got to treat this as a high-stakes problem. Look, in modern web development, any environment variable you prefix with VIT underscore gets automatically bundled right into the final code that reaches the user's browser. That prefix literally translates to public, meaning any secret you put there, yeah, it's not a secret anymore. If an attacker grabs those keys, they will definitely use them for massive spam campaigns, skyrocketing your cloud bills before ultimately getting your AWS account suspended. Basically, leaving this exposed means handing over total control of your infrastructure. Moving on to Section 2, let's talk about the BFF pattern. So to completely solve this vulnerability, we bring in our architectural savior. It's called the Backend for frontend, or the BFF pattern for short. And honestly, the best way to think about this is like a restaurant. Imagine your app is a high-end restaurant. Would it make any sense at all to give every single customer total access to the kitchen? You know, the place where you keep your secret ingredients and all the sharp knives, just because they want to order a meal? Of course not, that's absurd. The safe, correct place for the customer is out at the table, which represents your browser or your React app. Now, to actually interact with the kitchen, they need a waiter. That waiter takes the order, validates it, securely walks into the kitchen to handle the sensitive stuff, and then returns to the table with just the final dish. And right here, we see our technological waiter in action. In our case, a Vercel serverless function acts as that secure proxy between the React frontend and our AWS resources. The frontend, the part your customer actually uses, only sends a completely harmless request to an API endpoint. It never actually sees a single one of our AWS keys. The serverless function is the only entity authorized and fully capable of connecting with those protected environment variables and Amazon SES. All right, Section 3, getting our secure AWS configuration set up. Let's step directly into our kitchen now and configure that cloud environment using AWS IAM and SES. To really apply the principle of least privilege here, we never, ever reuse a human admin account to send emails from the server. Instead, it is absolutely mandatory to create a dedicated technical IAM user purely for this specific application. Let's call it SES Sender for now. We only give this user the bare minimum permissions it needs to function, like the Amazon SES full access managed policy, at least while we're in the learning phase. That way, if this specific user is ever somehow compromised, the damage is completely boxed in. Okay, pause. I need to issue a major frustration alert right here. This is a crucial pro tip. When you're generating those programmatic access keys for this new user and you select local code, you have to download that CSV file right then and there. If you accidentally close that screen without downloading it, boom, that secret key is gone forever and you're starting over from scratch. Also, please, if these credentials ever do accidentally leak to your GitHub repo or your front end, don't just try to hide them. You have to go straight into AWS, revoke them entirely, and rotate them immediately. Now, once that identity is totally secured, we head over to the AWS SES console, and we run right into this sandbox mode. Every single new account starts in this highly restrictive anti-spam mode. So what does that actually mean for you? Well, you're hit with very strict limits, a hard maximum of 200 emails every 24 hours, and a sending rate limit of just 1 email per second. But more importantly, you can't just email anybody you want. You can only send messages to email addresses that you have personally manually verified within the AWS console. Which actually brings us to another essential frustration alert. So many developers slam headfirst into the AWS message rejected error and just pull their hair out trying to fix it. But the root cause? It's almost always one of two things. Either they tried to send an email to an unverified recipient while they were still stuck in sandbox mode, or they're dealing with mismatched regions. Think about it. If you verify your emails in the US East 1 region in the AWS Web Console, but your app code is trying to connect to EU West 1, the service just won't find your identity. It'll bounce the request immediately. Absolute consistency across your regions is totally key here. Moving into section 4, let's actually build this serverless function. So, with the theory understood and our cloud impeccably configured, let's jump right into the technical implementation and build out our Node and TypeScript backend. Now, the absolute make or break point here lies in our environment variables. For our backend to work at all, it needs the AWS region, the 2 keys from our dedicated IAM user, and that verified sender email. So here is the sacred rule applied directly to our code. You must configure these locally without any VIT_prefix. None. By keeping their names pure, we ensure they stay strictly on the server, completely inaccessible to the front end by design.
Check out how we safely initialize the AWS SES client version 3 here. We're injecting the region and the credentials directly from the global process.env object. And notice that we do this right at the top of the file, long before we ever start handling any actual user requests. This keeps the connection primed, ready to go, and operating completely invisibly to whoever's making the request from the outside.
If we break down the handler logic, we can clearly see the layers of security in action. First off, we block any attempt that isn't an HTTP post method. If someone tries a GET request, boom, we throw a 405 error. Next, we strictly validate the payload to make sure it actually includes a recipient and some content. And look at this final block. This is my favorite part. If there's a server error while sending the email through AWS, our code safely catches it, prints all the juicy details to our private, secure logs, and then simply returns a generic 500 error message to the user. We never, ever leak the actual AWS error details to the client. And finally, section 5, the final integration with React. Let's close the loop here and look back at our customers sitting at their table. We need to integrate this hyper-secure endpoint back into our React front end to give them a seamless experience. We can walk right through this timeline. The user finishes their task, right? They click Send Summary. Instantly, React takes full control of the UI state. It disables the button and pops up a loading indicator. Meanwhile, behind the scenes, the fetch call fires off to the server, entirely out of sight. All that heavy cryptographic lifting, reading the credentials, connecting to Amazon SES, all of it happens safely away from the browser's DevTools. And finally, the backend responds, and the user gets a nice, instant, satisfying visual confirmation on their screen. So, now that you know exactly how to armor your email architecture, I just have to ask you, what other secrets, tokens, or database credentials might you be inadvertently exposing in your current front-end apps? It's kind of a scary thought, right? I highly challenge you to audit your entire codebase today, apply the secure proxy pattern to all of your integrations, and lock down your infrastructure. Keep learning, stay secure, and thanks so much for joining this explainer.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.